Okay, here we have a color verification application, and I've taken a live image and added in Paint the numbers 1, 2, 3, and 4, 5, 6, just to keep each vial separate. And ideally, this image would be zoomed in more, but let's work with what we have. Let's start with a color area to illustrate some points. We're going to size this for that area, and I'll click on the color area tab and we'll look at a color histogram. Okay, now you can see red, green, blue, 0 to 255, 0 to 255, 0 to 255, as shown here. It's the same thresholds. You can set here manually, we can set on the histograms. So we have 3 color models available: red, green, blue, HSV. This is like the color wheel. So red, green, blue is the native computer format. That's how the colors come in from the imager chip. We can convert that with a little bit of execution time to HSV. Hue is the color from red all the way through to 360 degrees if you picture a circle with the color wheel. And you can see here red on the left is 10, and over on the right 350, 340 is also red. So the problem with that is if we have a test color at 5 degrees and we have another color at 355, that's actually 10 degrees apart. But it looks like it's over 300 degrees apart. So anyway, we also have LAB. L is for lightness here in the top. A goes from a negative number for green over to a positive number for red. And B, the axis goes from a negative number for blue over to a positive number for yellow. And this model was created to mimic how people perceive color. So let's go adjust these thresholds tight on this first one. And we want to look at our score here. Our score is still 100%. If I get too tight, it should drop down. Yeah, we don't quite want to do that yet. So there's our score. And now I'll move it over to 2. Looks the same. 3, looks about the same. What about 6, 5, 4? They all look about the same. Okay, let's go to a color list. We're only going to make one color list detector. I'm going to click this so we only see our selected color list. And we'll resize it here. And because of what we mentioned with the HSV, and there's other reasons, I'm going to choose the LAB when I use the color list detector. So I'm going to teach 6 colors. I'm adding the plus 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 to get 6 colors. Let's start here with part 1. I'm on part 1, you can see up here, and I'll click teach. So now I'll move to 2, and on row 2 here I'll click teach. You can see these numbers are a little bit different. This color distance is a concept defined only in LAB space. So if you teach a color and you plot in 3-dimensional space the L, the A, and the B values, and then you have a test part, and you also analyze the L, A, and B, and you measure the distance in 3-dimensional space, if it's within 1, then the colors are indistinguishable. They're the same color to people. And a color value of 2 is the same to most people. And a color value here, this default we have of 5 is, most people could tell the perception between many of these colors that are still within the 5. So if you have very close colors, you may need to lower this. What we're going to do is we're going to keep teaching these. I'm going to teach 3, and then we'll go next. I'm going to teach row 4. I'm going to teach row 5. I'm going to teach row 6. Okay, and now let's check this out. So you can see here the result index of our detector. Right now it failed. It didn't detect anything, which is good. I should also add a 7th color to teach the background. I'm going to add an 8th to teach this other background. So here for 1, we found result index 1, which was the first row. 2, we found result 2. 3, we found result 3. 4, we found result 4. Can you guess where this is going? 5 and 6. So this happens when you use only one color list detector with multiple rows. And the only other problem with this is to get these out. If we look at the result, even if we say only detector 2, for an output, all of these pass. Row 1, 2, 3, 4, 5, and 6 all pass. So if you want to know which one, which color it found, what is the closest color, what you have to do is go here to your payload, and you got to use something like Ethernet IP, and you have to select the result index, which is this number right here, and you have to send that over either Ethernet IP, or you could use Profinet, or you could use Ethernet TCP/IP, where you would send the VISOR on software port 2006 the text TRG, and it will reply on 2006 TRGF if it doesn't acknowledge, TRGP if it does, and then it will spit out whatever we have in the telegram. Here it's a number on software port 2005 to your PLC or computer.